All right, guys, so we are skipping a lot this week. We skipped 8-3 earlier, and now I'm going to have you skip 8-6. Biggest reason is just because it does a lot of the lessons that I skipped, or the parts that I skipped of our lessons, and so it's not a good use of our time. And instead, we're going to move on to 8-7, which is parallel and perpendicular lines and line segments, which is a mouthful. So let's go ahead and see what that's all about. So if you'll make sure your SAB is open, this is going to be an important one to have nearby. And I believe, if I remember correctly, I don't actually know for sure, but if I remember correctly, these are things that you're at least semi-familiar with based on your third grade work. So parallel and perpendicular lines are the big things that we're going to talk about today. And right here it does the definition for you. So it says the lines or line segments in these pairs are parallel. And then it wants you to ask what it thinks it means for two lines to be parallel. Because on this side, they're showing you ones that are not. So let's take a look at this one real quick. We've got two lines. We see what's going on here. These two are said to be parallel right here. These two are said to be parallel right here. And these two are said to be parallel right here. But then on this side, these two are not parallel. So notice what's going on there. These two definitely not parallel. These two are not parallel, and these two are not parallel. So if we want to think about what a parallel line means, what I notice about the two of these is that this is wider on the top and closer together on the bottom, and that these are already crossing each other's paths, and these ones don't have anything that crosses, and they all seem to be about the same distance apart. So basically the gist of what a parallel line is that they are lines that will never, ever, ever cross paths, because they're the same distance apart from each other. If I were to take a ruler and measure from here to here, and it was 3 centimeters, if I were to measure it from here to here, it would still be 3 centimeters. That means that they're going to travel on forever and ever and ever, and they will never cross paths. So because this is a definition, I want to make sure that you write this down word for word with me. So make sure your pencil's ready. So this basically says two lines are parallel, and parallel is spelled P-A-R-A-L-L-E-L, if they are always the same distance apart, and then it says two lines are parallel if they never cross. Very important. Pause the video if you haven't had a chance to write that all down, so you can make sure you do that. But because I'm filming a 15-minute video, I'm going to move on. So now it here wants you to draw parallel lines. For number 2, it says draw and label a pair of parallel lines. And then this one wants you to draw and label a figure with one pair of parallel line segments. So this will be a good reminder of something we talked earlier about. Lines have those little funny arrows on the end to show you that they go on forever. So if I know that these need to be the same distance apart, what might be good is for me to just do something easy like this. So I'm going to start here, and I'm going to connect these lines right here. So there goes my line. And then do you see how this is like one little unit away? Let's go ahead and make it 2 units away. And no matter what I do, I just need this to come straight down. So those are exactly the same distance apart from each other. And they are lines that are going on forever and ever and ever and ever. Okay? Well, line segments, this says we want to have a pair of parallel line segments. I'm gonna challenge you a little bit on this one. I want you to notice this. So if I were to have a shape like a trapezoid, I'm going to draw a quick little trapezoid. It's not great, but it'll get the job done. Now this shape right here is made up of these different lines. And I'm going to draw these dots to show you that these are line segments. They don't go on forever, okay? And now, if I were to highlight here, this line right here and this line right here are technically the exact same distance apart, which means that these are parallel line segments. Now, if we were to follow these lines right here that I had drawn, eventually these would have crossed paths. So those are not the two that are parallel, but the two that I highlighted would be an example of parallel, okay? So now let's talk about perpendicular lines. Perpendicular lines are kind of sort of the opposite of parallel here. So for a perpendicular line, it says the lines or line segments in these pairs are perpendicular and that these ones are not. So let's notice the difference between the two. I see line segments here. Lines here. I see a line segment, some line segments, some more lines. This one seems a little more tilted. But then over here, I notice that these are a little bit more slanted, and this is a little more slanted. So I think I'm already starting to notice, I think there's something very specific about perpendicular lines, and that is that they are making a perfect kind of like a plus sign, you could say. And I know what that means, so I'm going to have you guys write down the exact definition again here for perpendicular. So this says two lines are perpendicular. Okay, perpendicular is spelled P-E-R-P-E-N-D-I-C-U-L-A-R. If they cross or meet, so this would be an example where they cross, and this would be an example of where they meet, to form square 90-degree corners, period. These corners, the corners are right angles. Check that out, okay? So basically what they're telling you here is that every single one of these, wherever they're meeting, is forming a perfect little 90-degree angle. Okay, so that has to be exact. So for example, if I were to look at these are not 90-degree angles. Those are less than. This is less than 90 degrees, more than 90 degrees, less than 90 degrees, more than 90 degrees. So those are all examples of ones that are not going to work. So I think about it like this. In a perpendicular line, you got to be able to have that right angle tester be able to work nice and perfect. Okay? So here it wants you to draw and label a pair of perpendicular lines. And so let's just think about it like an intersection at a street where you have a perfect stop sign. And so let's maybe do something like that. Okay, so I've got, it says to draw perpendicular lines, so I need the little line symbols. And I'm not going to worry about labeling all those parts. But for this one, it wants you to draw a figure with one pair of perpendicular line segments. And so this is a little different. This shows you like an intersection or like an XY grid. But on this one, you can draw shapes that are perpendicular. Basically, think of any shape that you know of that has a 90-degree angle. So for example, you could draw a rectangle. A rectangle would definitely have lots of examples that are perpendicular. But I also think of like a triangle. So here I'm going to draw a right triangle. And I can see that that has a little 90-degree angle right there. So any one of which you drew would have a little 90-degree angle. Okay? So the rest of our assignment today, we'll see how far I can get with you before I run out of time. But what I want to show you is your is basically how to make sure you're labeling this stuff correctly, and maybe if it doesn't actually even fit what it's supposed to. So this one says, tell whether each pair of lines is parallel, perpendicular, or neither. So here I've got a shape, and it looks like a plus sign. We kind of talked about that with perpendicular. So what I would have to do is use my little 90-degree tester to see if this is exactly 90 degrees, and I would then test all four of those corners. And if I could do that very quickly, I could see that this is indeed a perpendicular line. For today, I'm going to let you write it down as perp, just to save us some time. But then for number 8's hopefully pretty obvious to see. If I were to continue on this line and carry it on forever, these two are eventually going to cross paths, and they are not going to cross at a 90-degree angle. So because of that, we are going to say that this one is neither. Oops, neither. For number 9, we've got two line segments, and they seem to be the exact same distance apart. So we're going to call this parallel. And then number 10, I think, is also trying to trick me a little bit. This, again, looks to be a plus sign, and it looks like it intersects. But if I were to use my little 90-degree tester, I could very quickly see that these do not form 90-degree angles. And so because of that, it is indeed neither. Okay, so for down here, it wanted you to draw a pair of parallel line segments. Obviously, you're drawing on a piece of paper, so it doesn't have to be exact. But whatever you do, you just kind of want to make it seem like it's the same distance apart. That was pretty good. You could use a ruler, but no point to right now. And then it says, first draw a line segment 3 centimeters long, then draw a line segment 6 centimeters long that looks perpendicular to your first line segment. Well, I'm going to help you just it doesn't have to be 3 and 6 exactly. But here's what I want you to notice. If you had something like a 3 centimeter line, maybe is that long. Sure, why not? And it says it wants it to be a line segment. And then it says draw a line segment 6 centimeters long that looks perpendicular to your first line segment. They're telling you to then draw a 6 centimeter line segment that looks perpendicular. So it should look something kind of like that. I think it looks like a T upside down. Okay. So for the last part of this page, which we're going to do together, it wants you to use these lines on a map. And it wants you to talk about parallel and perpendicular as far as going to somebody's house. So this says, and by the way, this is northeast, southwest. That's going to tell us our directions to move. It says on Wednesday, Dell leaves his house and walks west along Lincoln Street. Well, west is to the left. So he leaves his house and he's walking left along Lincoln Street. Then it says Gigi leaves her house and walks east along Jefferson Street. So let's see that. She walks east along Jefferson Street. Okay, it says what kind of lines are Lincoln Street and Jefferson Street? Well, those two are the same exact distance apart, so we would call those parallel lines. For 14 and 15, it says, will Dell and Gigi ever meet? If so, where will they meet? No, they are never going to meet. And you don't have to write this all down, but that's because they're parallel. They'll literally never cross. For number 15, though, it says on Friday, Dell leaves his house and he walks south along 5th Street. So here's 5th Street and Dell is walking south along 5th Street. Gigi leaves her house and she walks east along Jefferson Street. East would be this direction right here. And then it says what kind of lines are 5th and Jefferson? Well, those create a perfect little 90-degree angle, so we're going to call that perpendicular lines. And then it says, will Dell and Gigi ever meet? If so, where? And you can see right here that they're going to meet at 5th and Jefferson. So yes, and they will meet at 5th and Jefferson. Kind of on that corner right there. Okay, so for your practice today, I'm going to give you 2 options. You can totally do your homework and remembering. That's a great option. I would be totally fine with that. Or you can go try out the homework and remembering IXL page, not homework and remembering, the IXL pages I set aside for parallel and perpendicular lines. Either ones of those will be totally great. Good luck, guys.